previous video, we showed the crack started on 3/8, but the report from Denny Pate's person, the contributing cause, inaccurate, misleading, and ultimately an untimely information from construction and inspection team on site. So you can see I just scroll right on down, and all of a sudden they begin the issue at 310, whereas we have cracks present on 3/8 and before. And so right there it shows how narrative is controlled sometimes. I just wanted to show that they just jump in on 3/8, on 310 and leave out 3/8, and also the bridge sagging. On all the details here, they don't talk about emails back and forth. It crack like hell pops. It comes in. It doesn't talk about the sagging. Let me move on. They just want to go in with blame the contractor for not roughening, and that magically causes a bridge to fail because quarter-inch amplitude, whatever. So I guess I should take this time again that they're talking about the quarter-inch amplitude of the interface of the deck and the 11 nodal area, which should also be 12. And let's talk about 11 pushing off 12. They just show 11 pushing off 12, and 12 offers apparently no resistance on weight for this. It punches, in fact, through, which doesn't make sense, does it? Why is it punching down as they have it, down through? Because of the load path. But that's a punching, right? It's not actually sliding at that point. That's a different argument altogether. But they have it sliding and punching through to create that crack pattern in OSHA report. I find that an assault of intelligence again. That one's still loading for you guys. And an attack on intelligence again, because number 12 has a significant amount of weight on it. They don't talk about the weight of 12. What's going on? Why can't I just get this thing to it's upside down now. Let's go again. Yeah. Oh. There we go. Yeah, you saw it. I said rotate clockwise, and that's what it did. It went from flipped it leftwise, but it still worked. I think I did. I don't know. But let's one more time dive into the image of that. Let me pause and don't keep me delayed. So they talk about they did this structural engineering firm that does analysis. They talked about this 11 interface shear. But yet, this is 11, there's 12. It has a dead load on it connected to this deck. It has 8,000 pounds of weight on it. How much of that, plus whatever extra force that might be created, and interactions with the reinforcement in there has to still be defeated. We see no rebar was defeated. So how do they have this pushing off and down, pushing down? They have it going away. They have it stepping away first off beyond number 11, and which is inside here, and then diving down. So it breaks around number 11 magically, the post-tension bar, but then it puts itself back again. It's just the stupidest thing ever. It goes around number 11, goes out beyond 11, then pushes down, causing this failure, and then it puts itself back into place where number 11 doesn't fail until till the bridge starts collapsing. It's just too amazing. It's too amazing. So again, they don't deduct for the post-tension bars. They remove them. They don't say that that's resistance. They remove them. But then they say a quarter-inch amplitude would have saved this bridge, is what they're saying. A quarter-inch amplitude of cuts inside here would have gave it the bite that it would not have been able to push 12 off, is what they're claiming. It pushed 12 off. But yet we clearly see 12s up in the air in the previous two videos. And pretty much all my videos, it's up in the air. But they have it pushing it off, and yet it goes up. And they have this structure, this member that's mostly cracked up and failed doing this pushing. Why am I beating myself up with this? I don't get it. So for everyone that wonders what the stirrups look like, these are the stirrups that are wrapped around the post-tension cables. There's only 2 of them in number 11. But there are 4 in the other, this guy, for example, this number 8 apparently. And there's 4 post-tension bars, 1, 2, and then 2 parallel below there. And then they're wrapped with all these stirrups. This is what they rip through. It would have to go through the stirrups. I'm sorry, the bars would locked into place, and it's got to come across the bars. This to slide it off. It's just, I just find it an attack on intelligence. And I just find it that all the engineers and these other groups that keep pushing on this shear thing, it's just an attack on intelligence. You know, I know you guys are intelligent, but what part of the post-tension bars inside here are in the way do you not get? They still have this sliding off. Yeah, the bond is not that great there. It pops off. We can see it fail off. We can see it if this is the true image of it. They didn't do anything like the OSHA report did, cutting it and said it's sheared off. And this report says it was burned off with a torch. So what is this? They're saying this is sheared off. This looks, if we can get closer to this, they should be able to identify this clearly as necking or sheared. It's one or the other. You know, it's a combination of both. But it's not something that they should have bypassed with data. That they could clearly give us a tight-end photograph of these pieces of steel here, and we would be able to look at it and tell whether it pulled apart or if it was sheared and pulled apart. So it might have been pushed over this direction and then elongated to where it sheared. They're saying failed rebar. There's rebar embedded in here in the stirrup capacity, so it didn't pull it all the way out because it wraps around. So we know we can find some rebar here. This is so telling of what took place in the direction of number 11 at this point. And then at this point, and surely at these points. We have 2 ears sticking out here, but I don't know how the ears came to be. Here, they're 2 little pieces of rebar. They appear to be in that direction, and also, but because they could be engulfed in here. We don't know where number 11 actually stops, number 12 picks up, and what was the intent of that steel. But this steel experienced apparently no shear and no elongation. I mean, you could count these and lay another bar of this size, bend it, and then cut it to size, and you would probably see it bend to the same radius. That this bar doesn't appear to be deformed at all. So it didn't take any of the forces on. They're just showing silly stuff there that means nothing at this point because I can't quite read it. But it means nothing. It says practice surface. I think I read it earlier. Failed rebar right there. So apparently there's some failed rebar. Why not say, well, how did it fail? Was it elongated? Was it sheared? What happened? How is this rebar failed? These guys are because it doesn't fit their narrative. Every bar would be speaking to exactly how it failed and what's going on. Every piece of concrete would tell you what's going on too. You know, as far as where did it belong. You know, not now. This is a pile of rubble. You could theoretically you could put it all back together. They all interlocked in some powder. You'd have to figure it out, but you could figure that puzzle out if you were that crazy. But that's not needed. This is cut out. This is saw cut out. This section here, and that's just try to show it. But then they use the overexposure to not show depth on purpose. Overexposing this, so it would kill depth. And this is a core sample, I believe. They took a core sample right there of concrete. So this angle they're doing, it looks like you can't get a core machine in there, but apparently you can. Or maybe they bent it and then took the core sample and then bent it back. Of course, that would be destruction of evidence. That's just stupid. How many pages left in this report? I think I'll just run through each report for you and make you happy with that. So this is the amplitude thing. We talked about that in a previous video. They just use this hammer, pointing chisel, hammered, small pointing hammered chisel. How about that? I forget the damn exact name. Brick pointing type hammer chisel. Brick. Gosh, I have 3 of these things. I can't remember the name. So they just showed that's how they create the amplitude with a chisel. I mean, to me, that's just excessive, chiseling it to get that depth. And this one now I can't quite see the roughness, but it doesn't matter because they don't do, when they do their testing, they leave out, then they just bypass, that this wouldn't just bypass, that there's a column sitting here that's stopping it, that it would try to run into, the number 12 column, weighing X amount of thousands of pounds, 8,000 plus pounds, plus whatever excessive other force it has, plus the rebar in it. So how is it able to push it? Well, they have it apparently changing directions, going downwards, and then in reality we see the tape measure and it's going upwards. The 12 columns going upwards, tied into the previous couple of videos for anybody trying to jump into this video and trying to know what I'm talking about. This is chamfer, I think, was added secondarily as the rebar. We see the stirrup, and the stirrup is in great condition, standing across, so it wasn't engulfed in this whole, and the whole entire collapse. It wasn't really party to that. I still can't be sure of this, but it looks like this goes all the way down to the concrete deck, which means no chamfer. Chamfer was added secondarily. I talked about that. The dates they pick up on last. Testing, pausing. No, I didn't really spend much time on this. Now I found it. I decided to race to the bottom of the page. This just looked like literature to me, and I'm racing through reading it. 91 of 107 of the report of FIG's presentation of party submission to the National Transportation Board. It says internal redundant members, and it's pointing times 3. So the deck, it appears that the outside, the truss system, and then the canopy, the times 3, the redundancy of self-supporting but not redundant is holding the whole entire structure. I think it's redundant as sort of sharing some of the loads. I don't think each one is capable of holding the other, because then you have, by their implication, you have a failure of 3 redundant systems, which is amazing, right? Fixed member connections, yeah, fixed. So not a truss, not fixed, all right. But we come down here. This is a tieback. That's why I jumped back up. That tieback system I'm talking about. This is saying design excluded cause. Common examples of less redundant bridges. Of course, you lose the cable, you're screwed. Connection right here, screwed. This is basically what they lost, but in the number 11 and 2 is what I'm stating. Yeah, okay. So they're just picking some sections. So no redundancy there. I'm just trying to think of what redundancy is here. And, you lose the support. This is, if you took this out, you lose the support of all this span here. What are they saying is still redundant? The other cable is still trying to hold that support up? Or would it? Is it designed to go to that much of a span? However, this cable comes down to here, and then this one comes down to here. I mean, that's a heck of a span. So there's multiple places you can find non-redundancy in systems. Excluded curls, restressing member number 11. RFC plans gave a construction sequence. Distressing the member of number 11 post-tension was a step shown in the plans and carried out on March 10th. MCM reported that the cracking worsened after the distressing. Restressing members 11 was reversing the previous construction step. That's what you thought you could do. Really, but it wasn't reversing because the cracks were so there. The cracks are not going to rebound and go back. Not in that position, not in that point, because they were moved. You said it pushed. Well, you didn't say that, but you can see this clearly in a different position now. That clamp force is one pattern, but the column is raising up into the sky. So how is that going to do anything? Bridge was supported at the same way with the same members stressing previously for 2 weeks, and the precast area with satisfactory performance. Bridge was supported the same way with the same members stressed previously for 2 weeks, and the precast area with satisfactory performance. This is not true because the cracks were not as large as they were, but we saw the cracks were there. So it's not supported the same way. The cracks would be something new. So test provided the members 11, 12 connected would not have failed with the post-tension bars re-stressed if the joint was roughened as required by FDOT. So they're stating that it would not have failed if the joint was roughened. So this company is discrediting himself. WJE is discrediting himself because they're saying it would not have failed. Would not have failed. So you would never want to hire this company to do your true analysis because they have no integrity, saying it would not have failed. That number 11 was structurally splitting, cracked, everything else as we've seen in the previous images. And they're stating it was the same and it wouldn't have failed. Then I wouldn't trust them for anything. They're not trustworthy. Their integrity, they can be purchased. Their professional statement can be purchased. This makes them a hack. It makes them a hack. And now we can talk about the hackness of them, if you will, and you'll see why. They said, excluded call full-size specimen test by WJE provide that number 11-12 joint would not have failed if the well, they didn't do a full size because they didn't add number 12. They only did 11. The number 11-12, they only did the 11 theoretical sliding system they did of number 11. They really didn't do it the same way. It looks like they, no, you didn't use the same concrete as they used from the same company. And the real same setup, not this extrapolation the way they did it. Yeah, it may seem about the same, but because you had the same angle of incidence, if you will, but not really. That's not true. You had to add the splits in it. They added no splits. So in their design of the bypass, and I'm going to stop this video with that one, because I got to keep this stuff short. So in their design of this WJE report, they show let me pause. So one, they're showing that this has got some drama happen to it. So they say it up here, that it's some twisting that took place. And so there's a problem here. So that's one piece that they talk about. But then they don't do it in their sample, in their model, in their theoretical model that they present using Illinois, I think at Illinois University. They don't present that twisting interaction. They don't show number 12 butting here, the forces that would resist that. And clearly, this is number 11, or this would be number 11, whichever one they configure. But if this is number 11, we don't see the cracks inside here. This would have to have a lot of cracks to show this. This would have to show the cracks. And then apply the forces, and now let's see what happens. This is why I say WJE is done a disservice to themselves doing this for being purchased. Right here, there should be cracks all up and down this theoretical model for this to work. No cracks are present in their theoretical model. So let me do this again. This will make this a thumbnail. In reality, the crack should be full cracks. Let me pause. And so here is the Fig Party presentation. This is Alan Phipps, professional engineer, structural engineer, senior vice president, director of operations. You got a bullshit degree in civil engineering. I couldn't help it. Master's in civil engineering, professional structural engineer, professional registered in 17 states, including Florida. 38 years. And yet, he doesn't have the ability to realize his own test is corrupt without adding the cracks. 38 years of experience, all this background, and he's a fucking idiot. We come to this guy who is the forensic structural engineering expert. He's worked on I-35 since 1979. He's done these investigations. Professional engineer, structural engineer, vice president, senior principal, bachelor's and master's, civil engineering, professional engineering in Florida. Again, he's since 1979, some connection there, so he's got, 30 years, almost 40 years, 30, 20, let's see, 80, no, 30, 40 years. 40 years, and he's another fucking idiot. They can't even use his own, it does a test on a sliding member that doesn't present the real field issue. So I find him also lacking. These are the people in real life. These are real people in real life. I find them disgusting. Now, I've been informed that this is an issue of the hard hats. This is the way OSHA is going to insist that hard hats be more like this mountain climbing one now, where they don't come off with a strap on it. So that could have saved the person, depending on how their head injury was. That could have been a coconut saver. It really is. I really believe in headgear. So I ask you, what part does this concrete look like the part of the concrete they tested? With these cracks in it, this cracks in it, this on both sides. What part of that looks like it can take a compressive force against a surface like this? Now, they'd also have to break off their base, because you can see that the path of this before is it's not quite. It goes, if I were to follow the path of this column down, it goes right about there and then drops down, and it's kind of a butted square end. They brought it to a point. Their design brings it to a point and a slide friction that way. So all of this would just be doesn't count to them. Then we have the column of 12 in the way. Its interface, its interactions, along with this chamfer that would, if you try to push down, slide, would butt 12. But we know it's a gap here, so it's not butting. Yeah, I'm ready. You come on out. Let me do one thing here. So what part of this, if this is the 11 part that's pushing on 12, the interface, what part of this looks like that? I don't see those parts looking alike. They'd have to right there do a chamfer, flat deck. It's not the same. So I am trying to visualize this, spin it around, and I'd want to see this interaction. And I want to know the weight, and I want to see steel there in the way. And then I want you to put not that little bit of silly rebar you put in there. I want you to put the post-tension bars in there, because they were there. But everybody keeps removing these post-tension bars because some damn formula, some idiot clown in one of the damn AIC, CBS, ABD, American Concrete Institute statement said, remove those when calculating blankety blank. That, or somewhere, one of those institutes said it, that they base it on the removal, that they should theoretically remove them. It's ridiculous. Those things take hundreds of thousands of pounds of shear force to get through them, and you're just discounting them. You're throwing them in the trash. You're throwing them in the trash. Those things loaded out to 288,000 pounds of force. Pounds of force, or was it? It was kips. Yeah, thousands of pounds of force. 288, and an ultimate failure greater than that. But there are two of them in here. Now put them in there and try your little damn compressive toy thing and see what happens. So I'm using this report to help me debunk. There's testing that they did to help debunk NTSB and themselves. That this, and also the ridiculousness of it, how they actually did a model, they put it here, and NTSB said we don't like we disagree with their model and everything else, because their model mirrors exactly what NTSB is talking about. Their model is what they're talking about. You just remove the bars, put this here, and do that sliding, and forget all this other stuff, this other way, because even OSHA doesn't talk about the rebar being in a way, this rebar being in a way. It's only this rebar, that's it. It just has to push through this rebar only by OSHA and NTSB. Not out here. This doesn't exist to them. And the post-tension, the bar, the two bars in there, they also don't exist. Also, what doesn't exist to them and or NTSB are these cracks. They don't exist. How they happened even, they don't exist. They don't matter, because all they see is we're going to do this, and this is what, it's ridiculous. I'm stopping this video because obviously I can't take it. I'm a little weak person.